Welcome to today's First Chesapeake Chats session. I'm Victoria Mulvihill, a First Chesapeake alumni, and I'm here to introduce the First Chesapeake Chats sponsored by Newport News Shipbuilding. Just some housekeeping, we'll let the speakers present and then open up for discussion questions later on if there is time. But please feel free to put any questions in the comment section throughout the chat and we'll try to get to them all. The session today is Learn Something New, using AutoCAD to design a chassis belly pan, presented by Team 1885 Eiler Robotics. And I'll pass it over to Katie to introduce everyone.
Hello, we are from Team 1885 Eiler Robotics in Hammark, Virginia. My name is Katie.
And I'm Matthew.
Hello, I'm Akshita.
And we're going to be talking about how to use AutoCAD to create a belly pan. Now I'll pass it off to Akshita to talk about what AutoCAD is.
So Akshita's having some technical difficulties, so I believe I will take over until we have her back. So AutoCAD is a software made by Autodesk. They're widely known for making different softwares used throughout the industry and a lot in FRC. You may know them from their popular CAD softwares Autodesk Inventor and from the FRC field simulation Autodesk Synthesis. AutoCAD allows you to draw out different two-dimensional shapes and designs using its built-in tools to make plans for anything. Why do we use AutoCAD? AutoCAD inside FRC, us as a team, we use it to design our belly pan before we actually start CADing and laying everything out in a physical manner. Outside of FRC, though, AutoCAD can be used for a lot of different things, including architecture, both interior and exterior, as well as like things that are a bit more simple, like logos or maps. So I'm going to hand it off to Katie to talk about AutoCAD basics.
Thank you, Matthew. So to start off with AutoCAD, first you need to download the software. This download does take about 30 minutes, so you probably won't be able to follow along with us for this presentation, but feel free to come back and rewatch this. So we've written out all the steps for you to be able to find it. You can feel free to take a picture of this if you want to, but basically you Google AutoCAD, and then once you're on their website, you go to the menu and choose Students and Educators, and then you click on the Download Free Software area. From there, you can select on AutoCAD, which is the software that you want to download, and then you would either make an account or sign into one you already have with Autodesk, and then select the version and operating system you want to download. Once everything has finished downloading, you'll have a screen similar to this picture here. And then to begin, you'll press on the Start Drawing button to the left. Now I'm going to pop over to AutoCAD that I already have downloaded. And I just have up here a basic screen of what it will look like once you've clicked that Start Drawing button. Up here at the top, you can see what different shapes you can make and the different tools that you can use in AutoCAD. To practice with some of these, we're just going to start off by making a basic PDP design. So here's the rectangle tool, which we're probably going to be using a lot throughout this presentation. And here it'll ask you to specify your first corner. So you will click, and then you can drag around to however big you want your rectangle to be. I'm going to start off with a pretty large one to be the base of the PDP. Now I'm going to grab the rectangle again and make a skinnier rectangle, and this is going to represent the ports that you can be plugging things into. To create the other side of ports, I'm just going to click on it and do Control-C and Control-V to copy and paste it over to the other side. I'm going to grab another rectangle for the can and then some small squares for where the battery could plug into. Down at the bottom, I'm going to add another rectangle for where you would be connecting the Rio, VRM, or PCM. Now, once this is all finished, it looks pretty good, but as of right now, it's just a bunch of rectangles, which don't really mean anything. So you can use the text option up here to be able to label things. You would again specify the first corner and then drag to see how big you want it. So I'm going to do about there, and then just type in some numbers for the ports. Since these are pretty small compared to my rectangle, I'm going to select everything, and then up here where my mouse is, you can change the height of your numbers. So I'm just going to type in 1, and that'll be the height. If these aren't in the place that you want them to be, to move them, you can just select it and use this square to click and move them around. Or once they're all selected, you can choose the Move tool and then select a spot to move them around by. You can use the text tool to label all the other things on your PDP, such as the CAN or the Rio VRM PCM. I'm going to come back over to the presentation and hand it off to Matthew again to talk about creating some more components with you guys.
Thank you, Katie. So now that you guys have a basic understanding of how to create a simple component like the PDP, I'm going to work with you guys and actually create a couple more key components that you're going to see in most, if not all, belly pans. So that's going to include the Robo-Rio, which is going to be one of our more complicated ones, a VRM, a SparkMax Neo combo, and a battery. Now, you were obviously not limited to these components. In our final design for last year, we had everything you would see on a belly pan. We are just doing this for demonstration purposes to limit how many things we're actually going to be working with. So I'm going to jump over to AutoCAD. And you can see I already have a PDP that should look similar to what you did with Katie. So we're going to start with the Robo-Rio. I know we're going to start with the most complicated one, but it will make sense later. So for the Robo-Rio, I'm going to draw out, let's say, 16 by 16. So that's 10, 15, 16. And a Robo-Rio has a lot of different inputs and outputs for different connections on the component itself. We can add a rectangle for a possible connection for every single input and output for the Robo-Rio. But let's be real, we might not be using things like the USB port on this specific belly pan design. So I'm going to limit it to things you're mostly going to see within a belly pan. So we're going to start with the digital outputs or inputs. And that's going to be, I think that's 10 connections. So we'll go up that many. That looks good. Now the relay section is actually the same height, so I'm just going to Control-C, Control-V, and add that over here. We have the relay and analog section on the bottom, and that's going to be 4 for analog, and the relay is another 4. So that takes us here. And then there's one down here for the RSL. Trying to keep the boxes that we draw within the grid lines just to make it a bit more readable when you're looking at this in the grand scheme of things. And we have a little triple pair over here for the CAN, the I2C, and the RS connections. So we're going to separate that into 3. We have our power. And you'll notice throughout this entire design that we only use one connection for power, even though typically for power and pretty much everything else, there's a positive and a ground or whatever you want to call it. But in 95% of the scenarios on a belly pan like this, the positive and the ground are going to be going to the exact same space. So there's no point in drawing 2 connections. Now, the only time you'll see this different is with the battery connecting to the PDP. And that's because we're typically going to have a main breaker separating one of those 2 connections. So I'm going to go ahead and continue here. I I don't think I need any more for right now, so we'll add a little bit of text in here. Draw a big area. We like to label all our components, so we'll label this the row and Rio. You gotta click away. And a little tip, if you want to make the text bigger, we're going to go to properties. It's going to bring up this little window. You can look for text type. Ooh, I'm not sure what happened there. 1. There we go. Ooh, that's a little too big. Let's try 0.5. That'll work. Gonna close that text box, and then we'll make this grid a little bit bigger. There we go. And we can, that seems like a good spot. Now we'll add our relay and analog section over here. I'm going to be a little lazy, and I'm actually just going to make them the same text box with a little bit of space between them. And then we have the digital and the PWM connections. So over here we have the DIO. Over here we have the PWM. Now we can go ahead and rotate these using the modify section up here. I'm going to rotate, and it's going to ask us to select a base point and then an angle. It's pretty simple. We'll do it one more time over here. I'm going to go rotate, base point, flip it down. There we go. And we have our last few up here. They're going to be, we're going to make these a set of 3. We have CAN, ITC, and RS. Looks like that text might be a little big, so we'll make that a little smaller. We'll make that 1/8. There we go. And then for our last one, we'll add the power ground combo. There we go. So obviously you can take your time and try and make this look as pretty and organized as you want. For time's sake, I'm probably going to leave it there and move on to the next component. So if you remember, we also want to do a Spark Max and a Neo combo. This one's going to be a little easier. We'll just make a, 3x6? I think that's 3x7. We'll make it a little smaller. You can select the rectangle and grab that middle bar, and that will allow you to move it along the true X and Y axis. So in the center, we need 2 CAN ports, because when you're daisy chaining, you need an in and an out, or 2 jump points. And then we need an input for power and an output for power. Now we'll go ahead and, just like the Rio, we'll add our text in here. So we'll call this a Spark Max. And then, you have to select the text tool every time. We'll add CAN down here. And then I'm going to refrain from labeling the input and output, because if you wanted to move it to the opposite side of the PDP, you would have to obviously switch the input and output. So I'm going to add our Neo. My version of a Neo is just a couple rectangles with a single connection, and we'll label that Neo. We can move the text, make it a bit more organized. There we go. Now, for our overall belly pan, we don't want to obviously have just one motor, so we're going to copy and paste another one in here. All right, and then another easy one, we'll get the battery out of the way. We'll say that looks like a good size. We got our positive and ground. Ooh, that looks a little big. Yep, we're going to make that a little smaller. And then we'll add our label in here. We'll call it battery. And then we'll label our positive and ground. Oh, I think AutoCAD likes to kind of mess with things. That's okay. Thinks we're trying to do math. Then we have a VRM, which I think is going to be our last one. I believe so. Yep. All right. So we'll draw a VRM, which is going to be a 5x8. I feel like that's good. We're gonna have, so this one's gonna have a bunch of rectangles. So we're gonna have 2 here. Now this is where your copy paste tool is gonna come in handy, because I'm just gonna take all of that, I'm gonna copy it, I'm gonna paste it down here, paste it down here, paste it over there. And we also need an input. I'll put that up here. Go back to home. Let's add our labels now. VRM. We'll call this the input. And then let's do over here. This is our 12 volt 2 amp. We're gonna make this text a little smaller. Go back to text height, if you remember. Make it a quarter. I feel like that looks good last time. Yep, that looks good. Now, so I don't have to change the text height every time, I'm just gonna copy and paste the text, and I'm gonna go ahead and edit it once I paste it. So over here is gonna be our 5 volt 2 amp. Paste it down here. This is gonna be our 12 volt 0.5 amp. And finally, we have our 5 volt 0.5 amp. So just like I said last time, you can take some more time to organize these and make them look a bit cleaner. But for time's sake, I'm going to go ahead and move on. And I'm going to go back to the presentation to just talk about one little key point that I want everyone to realize after going through and making all these. Here in the next couple of slides, I have the real-life version compared to our team's personal AutoCAD version. So you can see the Robo Rio. There's our VRM. Some of these should hopefully look familiar. Your SparkMax Neo, your battery. And what I want everyone to realize is that it's not the size of the component in real life that's directly related to the size of the component in AutoCAD, but rather the amount of things that it has the potential to connect to. You can see this especially when looking at the battery. The battery is one of the largest things that goes on your belly pan or wherever you put it, but in AutoCAD, it's one of the smallest things. And just a little tip, whenever you're designing this, remember that that size part doesn't correlate exactly, but it is important to work with a real life photo or object for relevance. So I'm gonna go ahead and hand it to Akshita because I believe she's all good to talk about AutoCAD layers.
Thank you, Matt. So, sorry about the technical difficulties. My computer's been being a little weird. But in AutoCAD, to denote different types of wires, we use layers. And the method used for creating these layers can be used for any type of wire that you want to. We're just using CAN and power for the purpose of demonstration. So we'll go to AutoCAD right now. And here I just have a bunch of the parts that you made earlier. And we could start. So here is where everything you need is gonna be. To access your layer. To access your layers, you're gonna need to go to Layer Properties. And here we have the layers that are on right now. To create a new layer, just click this little button with the star. And then you can name your layer whatever you want. For demonstration purposes, as I mentioned earlier, we're just going to do CAN and power. So I'll make this one power. And then for the color, we're going to make power red. Now, and then if you click down there on the scroll down, you can find power. Click this button to make it your current layer. And then if you just click line and draw a line, you can see you've got a power cable. And then we can do the same exact thing to create a can layer. And then change the color to green. And no. Yeah. Oh no. This is why you have to make sure that you set your layers straight. So now you've got your can wires. And basically, Matthew will show you later how to actually use all of these. And here, along with your layers, if you click this button, then you can turn certain layers off. So right here, just click yes, and then you've got all of the green turned off. And then to turn it back on, just click that button, just click this button to switch it on. You can also isolate your layers, and that, as showed earlier, this button makes your layers current. And to make sure that you're not editing any of your other layers while working on another layer. So basically, like, pretend you're working on can, and you want to make sure that you don't mess up any of your actual components. Then you can just click the drop-down menu, and you can click the lock button, which will lock your layers. So then you can see we cannot tamper with any of these. Or also just click the lock button right here. And now I'll pass it on over to Katie to talk about organizing components.
Thank you, Akshita. So when you're creating your belly pan, you want to keep things that have a lot more connections more central. This makes everything a bit more organized and reduces the amount of wires that you need to cross over. So I'm going to come over to AutoCAD. And here I have just some of the parts that you should have made with Matthew earlier. And we're going to work on placing them in a way that you'll be able to connect everything nicely. So I'm going to start off with the PDP. And I'm going to move that over here to this nice little central location. Then I'm going to grab the SparkMax Neo combinations, and I'm going to put them towards the side of that. That makes your connections nice and easy and keeps it kind of short. Next, I'm going to take the battery, and I'm going to move that up to where it's going to be connected. Again, keeping things nice and close so that your connections aren't too long. I'm going to move the VRM over next to the battery, and then the RoboRio over here. So this keeps everything in a nice central location. The PDP is in the middle because if you were to have a lot more SparkMax Neo combos or things of that nature, then you would have a neater looking belly pan. I'm going to come back to the presentation and hand it over to Matthew again to work on connecting some of those components.
Thank you. So now we understand layers and we have our belly pan laid out. We actually want to draw out our connections. So I'm going to move over to AutoCAD, and I have a layout similar to what you were doing with Katie. I think the only difference is I moved my VRM from over here to up here. So we're going to start by moving to our 12-volt layer, or our power layer, and really just get started. So we'll start with our SparkMaxes, and this is where I'm going to point out something important when designing your belly pan. When you have connections close like this, it looks a bit better when you try to keep common connections in closely knit parallel lanes or areas. So it's a bit more understandable to see 8 connections coming from the PDP and going to 8 different SparkMaxes, rather than if you had each connection jolting off into a different direction. So you can see I'm trying to keep the connection lines close together. And I'm going to connect our Neos to the SparkMax. And then here's another easy one. We'll get the battery out of the way. It's just a straight shot. Try to keep our connections in the center of the square, again, just for visual purposes. And then here's a little tricky one. So we need to bring VRM and Robo-Rio power from down here all the way up here and here. So what I'm going to do is I'm actually going to start at the Robo-Rio. I'm going to work my way down the side all the way down here and straight into the Robo-Rio power. And then for VRM, I'm just going to follow the path I just made for the Rio, going all the way up and around. But instead of going to the Robo-Rio, obviously, I'm going to go to the VRM. There you go. That is all the power connections within the belly pan that we're doing here. But we still have to do CAN. So I'm going to move to the CAN layer. And here we are going to learn about arguably one of the most frustrating features of AutoCAD. It's called the arc tool. Now, the arc tool is how we like to show connections moving over top of one another. And so you can kind of see that it's trying to get you to make a semicircle or somewhere in between, but it doesn't allow you to make the perfect like 180. So to do that, we're going to move these base points around, trying to get them in a readable format. I like to have the arc on the top, again, just for visual reasons. It's all up to preference. And then I'll go ahead and bring this CAN line down. And since we're going to daisy chain everything, I'm going to start with the spark maxes. Ooh, I need to do another arc there. So we'll set base points. There we go. Ooh, looks like I forgot, it's best to move the center one before you do any of the others. If you have a line coming straight into the arc, it might be better to move this top point to the bottom. And then I'm going to continue this line over to the spark max. And another thing we really like to try and avoid is going over text, but in some cases that's just not possible to avoid. So you can see here, I'm just going to go over top of it, although I'm not a huge fan, but it's better than having the connection going along a long path rather than just going over the text. You can see I could probably bring it down here, but I'm just going to try and finish up quickly. So I'm going to put one more arc in here. So you got to move the base points around. And then I'll continue this line all the way around, going up to behind the battery. And just for time's sake, I'm actually going to go around the battery so I don't have to do more arcs, because arcs are, like I said, one of the most frustrating parts of AutoCAD. So I'll go up here, and I'll come straight down. And the PDP in our real life scenario would be our terminating device. So we would have the terminating resistor here. Obviously, your belly pan may have more components and might not terminate with the PDP. It's all up to personal preference. And there you have it. You have completed your own mock belly pan within AutoCAD. And before we finish up, I just have one last thing back in the PowerPoint. You can see here is what my personal adaptation of this belly pan looked like in testing. And I have an ending challenge for everyone. You can see a picture of our 2019-2020 AutoCAD drawing. Looks a little bigger than what we just did. But I want to challenge you guys to include a pneumatic system in your personal belly pan. This includes creating a new layer for all your pneumatics lines. You're going to have to draw on new components like a compressor, a PCM, all a bunch of things. And it will be a challenge, but I think you guys are ready. Thank you so much. And I believe that is all.
Thank you, Akshita, Matthew, and Katie for being here with us today and sharing such important information. And I really like your challenge. I am not the most experienced in CAD, but I do have some. Might be fun to try out. And just once again, I would like to thank this session's sponsor, Newport News Shipbuilding. We have a short video from them, so please stick around and have a great rest of your day.